Good evening, everyone. Welcome to the fourth day of our faculty development program on unlocking innovations with blockchain and generative AI. It's been an incredible journey so far with enlightening discussions and thought-provoking insights shared by our experts in the field. On day one, we laid the foundation with an overview of blockchain and generative AI. Day two expanded our understanding of advances in LLMs and chatbots. And yesterday, we explored generative AI tools in education and learning platforms. Today, we dive into two fascinating sessions, that is AI-generated synthetic data for machine learning by Mr. Prashanth Ivaturi, a domain expert in leveraging data to unlock AI's potential. Session 2 focus on building an AI-first mindset for the future workforce by Mrs. Priyanka Kamath, an inspiring leader in AI adoption and workforce development. These topics are vital in shaping the future of academia and industry, and I encourage everyone to actively engage with our distinguished speakers. Let us begin this evening's exploration of how AI innovations are reshaping the world around us. Now, it is my pleasure to invite our first speaker for the evening session, Mr. Prashanth Ivaturi, to share his insights on AI-generated synthetic data for machine learning. Sir, we are eagerly looking forward to learn from you. Over to you, sir. Sir, Prashanth, sir. Prashanth, sir.
Incoming call from Shankar Aradala identified by Truecaller. Shankar Shankar.
Prashanth, sir.
Hello, good evening, ma'am. Are you able to hear me?
Yes, sir.
Okay, I think there was some issue with the audio on my side, because of which I was.
Now it is okay, sir.
Hello, ma'am. Am I audible now? And is this clear? Hopefully,
yes, sir. It is clear.
Yeah, it seems like the network is probably a little patchy today, unfortunately. But anyway, let's see. Let's see how. What I will do is I'll try to, as long as this is working, I'll try to quickly speak through and explain what about the synthetic data for machine learning. That's one part. But before that, again, I'm really grateful for this opportunity to share my experiences with the rest of the faculty and the students for a second time. I know we spoke about the LLMs and chatbots a couple of days ago.
Sir, your audio is muted, sir.
So one of the things that Dr. Kalavati Garu mentioned was that, what could be certain areas where or research topics that you could probably look at in terms of LLMs and the advances in chat GPTs and the chatbots. I'd say there are plenty of use cases. In fact, if you look at the entire landscape of LLMs and chatbots, there's quite a lot of things that are moving in that area, right? Now, one of the things which is picking up or has picked up quite a lot of interest amongst people is multimodal integration. When I say multimodal, we didn't touch upon that multimodal aspect of LLMs and chatbots, but imagine, you'll have several touch points for with a person, right? I mean, when we are, we don't only type all the time. We don't always use text with LLMs or chatbots. Our integration points or our points of touching with technology is multifaceted, right? If, like I was mentioning the other day, if it is a customer service, right, we may probably use a mobile app, a mobile phone app, and say, okay, let's raise a service request. So we probably use an app and log it, or sometimes we have to email to the customer care. So those are more methods where a textual email kind of feature is coming in. So the company or the people sitting on the other side have to understand it, right? But now let's say you pick up the phone and you also have to talk to the customer service representative saying, hey, I sent you this email, I did this, I did, and you're probably frustrated, right? Now the customer service agent understands a lot more of your intentions and the kind of emotions that you're going through. So in these kind of cases, what is happening is it's not just only the textual knowledge of what is being looked at from the data, but there is a deeper understanding of your emotions and all of that. So as I was mentioning on Tuesday, that there is natural language understanding. So some of that is required underneath, not just natural language processing, but natural language understanding, and understanding of the intent is very, very important. Number two, when we say multimodal, we also need to think about not just speech. It could be imagery, it could be voice, it could be video, it could be some other kind of content, right? So different kinds of the content that has to be processed. So I'd say research a little more around the multimodal integration and what kind of use cases the industry will see. If you have questions around the multimodal pieces, we can talk about that. But that's definitely an area which is picking up quite a lot of the interest. And if you look at the customer service kind of areas, there's a lot of companies which want to improve upon their conversational AI mechanisms and use multimodal integration. That's one. The second one is around the ethics and governance. There's a lot of research that can be done around in this area because this is evolving, and there will always be this tug of war, that's push and pull around. We are making advances in LLMs and chatbots, but to how far can people actually extend that? What kind of ethics related policies do we want to incorporate? How do we make sure that we are able to have governance mechanisms around these LLMs and chatbots very, very well? So that's an area of research that's picking up, and there is not a lot that has happened. And if you think of not just the LLM governance, but if you look at a lot of the policy making from the government as well, the policies have not yet come out around these. There's much more broader AI governance strategies and all of that, but not a lot of policies. So that is another area where we can actually spend some of the time. Then in the traditional AI ML space, which is the machine learning data science kind of thing, explainability is easy. But how do you explain the outcome that a black box like a large language model is throwing at the users? How do I trust that it is factual? Like I was giving the example the other day about the songs that I was searching about, Ilayaraja versus A.R. Rahman, and factually it gave me incorrect ones. Then is there a way to look at explainability for LLMs? And if we are able to make that breakthrough around explainability and interpretation of those results, that is when people will start trusting LLMs a lot more. And don't think of just one single user. Like, you know, if I search something on ChatGPT, I might probably trust that result. Okay, but there may be people who will not trust the AI, what the outcome it is generating. Similarly, enterprises will be very cautious about the results it's generating, the data that it's being fed. So in that sense, that interpretation and explainability of why certain results are coming through, I think that has to come through. Because these are deep neural networks that we're talking about, there's not a lot of explainability that comes along. It will summarize it, but I think some level of that explainability and research around that will be very interesting to see how we can generate some analysis and produce that. Right now, so like that, what else can be done, right? I mean, can we extrapolate some of these research use cases to maybe specialized domains? Healthcare, for example, or maybe the automotive sector. If we are able to make these LLMs very highly specific, then I think that's going to be another big challenge that we would be able to overcome. In fact, I was reading about a doc LLM, which JP Morgan Chase has worked upon. There's a podcast. If anybody's interested, we can talk about that. They used one of the existing LLMs, open source existing LLMs, and then built out additional capabilities that allowed them to look at these documents, right? Now, reading those documents. Now, there can be contractual documents, legal documents, which run into thousands of pages and whatnot, and there a certain format in which we want to do. So that doc LLM is what they were able to build out. So like that, there are several use cases that we can touch upon from a LLM and chatbot perspective. Okay, so I wanted to just take maybe about 5 minutes or so for touching upon a few broad themes and within your area of interest. And these are not just the overall umbrella, but there are many more use cases like that. But if you can think about some of the topics around these, I think that will be a very good starting point to look at how we want to explore a lot more on the research side. But plenty to think about, right? And people all over the world are looking at various different use cases, various different research topics around these. So we can probably have many more ideas like that. So that's that. So I just want to cap it off with that from the LLM and the chatbot session from last Tuesday. Any questions around that? If not, we can jump into the synthetic data for machine learning topic. Hope everyone is geared up for that. Okay, all right. Yes. If there are no questions, then let's move into it. Let me just start projecting my screen. And while I bring up the screen as well, I also want to call out, I did attend yesterday the session by Ms. Nishtha Rohatgi as well as Mr. Pankaj Diwan. I missed a bit of Ms. Rohatgi's session, but I did catch quite a lot. So I think it was very interesting, to say the least, because there were quite a lot of different tools that Ms. Rohatgi talked about, right? And very aptly put there, because we need different kinds of enablers and all of it, right? And then I also quite liked what Mr. Diwan said about it's not about having or knowing these tools, right? And the reason I bring this up is because I want to be able to connect the dots with what we are talking about, the synthetic data as well, right? It's not about the knowing what kind of tools there are, or not trying to learn about coding, or maybe saying, okay, I have this tool at my disposal, I want to use that. But more importantly, I think we all collectively need to think about, right, always at the top of our mind is, what is the problem that we are trying to solve? Okay, when I did my MBA, one of the things that we were told is, especially when organizations are putting millions of dollars of money into cutting edge research and all of that. And then we need to understand why is that money being poured into it, what is the underlying problem that we are trying to solve. And sometimes even after pouring in a lot of money, the underlying problem is not solved, because there could be some other challenges, or maybe people are not solving the right problem. So before you get to the actual tooling part of it, or knowing, okay, what are the technologies and things like that, I think we all need to understand Mr. Divan rightly said that, you need to learn about the domain. You need to learn about the problems that you want to solve. Because when you have a good understanding of the problem that you want to solve, then the way we think about solving it changes. We think about, okay, in order to get to those outcomes, what are the various tools, technologies, means that are available to us that we can apply in order to solve the problem, right? So that is a very important and very relevant point that I want all of you to bear in mind, because that's the biggest thing from a in the industry that we always think about, right? And I know some of you rightly asked this question as to about there is a huge gap between academia and industry, right? So this is one of the ways in which industry thinks about, because in the industry it is more capitalistic, right? In the industry it is more capitalistic, meaning people think about, I have got a limited budget. With this limited budget, what kind of problems can I solve, and how do I prioritize the biggest problems that I can solve, right? Now, if we take that same theme or that same thought process, it can be applied to each of the topics as well. Say, for example, LLMs. Now, if I have limited time and limited resources, if I have limited money, funding, whatever it could be, what are my top 3 problems or top problem that I want to solve? Can I solve 3 problems? Can I solve 1 problem? Can I solve 10 problems, right? Depends on all the resources in balance, right? So that is the most important aspect. Now, use or extrapolate the same kind of theme, same kind of thought process, even when we are talking about the synthetic data for machine learning, right? Now, why is that important, especially from a machine learning perspective, is because, and let me start sharing my screen there, sorry. I hope I've been audible so far, right?
Yes, sir.
Yes, sir.
Okay, perfect, good, thank goodness. Now the internet is not acting up then. Okay, and you're able to now see my presentation slides as well, right?
Yes, sir.
Okay, good, great. So if you talk about AI generated, we don't have to go through this one, we already talked about. So data for machine learning is very, very critical. It is absolutely necessary for the machine learning outcomes to be absolutely accurate, right? So we'll spend a little bit of time on maybe just as a context, especially for those who are not familiar with machine learning. I think that's why I wanted to just maybe take a step back and talk about data for machine learning, why it's important. Second is, then let's understand synthetic data, right? And see what exactly do we mean by synthetic data? Why is it important? What are some of the techniques that we are going to look at? And then applications of synthetic data in machine learning and some of the challenges, right? Because this is absolutely critical. We need to, again, like I said on Tuesday, we need to have a holistic perspective of why are we trying to do this and what kind of issues can I run into? So in the business world, and I'm pretty sure some of you will be either have worked in the corporate sector, or some of you have worked in the industry, some of you may be going on to work in the industry, you may be going on to solve some problems for the industry, in whatever capacity you are going to look at it, right? Now, as I said, as I was saying earlier, that AI is currently the flavor across the world, and which means that underneath all the different technologies that we are going to be working with, whatever problem it is, technology is going to solve it, and for good or worse or whatever it is, AI is going to be part of that. Every organization has mandated, which means that there is going to be some sort of machine that's going to learn from the data that is out there, right? So AI plays a critical role, and for AI to be successful, the data plays a very, very critical role. So when I talk even from a marketing perspective at Oracle, right, we've been talking about machine learning. We have implemented several ML models internally for our own purpose. But then every single conversation that we go to with the leadership, one of the biggest questions that comes in is, hey, how good is your data for the machine learning to actually predict accurately, right? And what's the source of truth for it? So say, for example, I'm just giving a very, very simple example is now at least we have Aadhaar, and we've got the PAN card. So there is some level of data which is probably synced up, right? But even today, if I look at some of the different identity cards that I have, my family members have, some of my friends have, my name is written or spelled incorrectly on some of the in some of the forums, right? In some of the places, my date of birth would be and have been entered incorrectly. My Aadhaar and my PAN card or all of that, they sometimes would not match for the data exactly. Probably it's also some operator made an error and things like that. But that's a human error that is getting inserted. Now imagine like that, if there are several points where data could go wrong, then how are the machines going to learn accurately? It's very difficult, right? So it is absolutely a very valid question for us to say, if in case machines have to learn from data, that underlying data has to be of really, really good quality. It has to, we need to make sure that the data is accurate, right? If not, the machines will only learn only as much as the kind of data that we are going to feed them, right? So that is very important. Now, the relevance of that data is absolutely necessary, right? I mean, if I want to understand behaviors of the behaviors of a certain person, of how they are, what kind of products are they browsing on a Flipkart or Myntra or Amazon's website and so on and so forth, I need to look at the behavioral data, right? It is insufficient for me that if I'm getting only some demographic data of the person, so therefore that relevance of that data is absolutely critical. We need to have the right kind of data there, right?
Sir, your mic is muted.
Sorry, there was a slight internet connectivity disruption there.
Okay.
So there was so data preparation is another very important aspect, right? I don't, if I've got like a million records of data with several columns in a database, I don't need every single attribute. Not every single attribute is relevant, right? For example, if I want to look at outcomes of, tell me how many, if I've got the whole population data of the state of Andhra Pradesh and Telangana, or maybe this entire country with me, I don't need every single attribute in terms of when did I get my COVID vaccine, or where do I live and things like that. If I want to predict or if I want to classify my data set into saying male and female, or people who are falling in the category of the age group of 0 to 20, 21 to 40, 41 to 60, and so on and so, something like that, right? So I don't need some certain attributes or certain types of data there for the model to actually I need to prepare it. And similarly, if the date format, some places or some states have entered data in the DD MMYY, some of them have entered it in MMDDYY, I need to prepare all of that data to be in a consistent format for my machine to understand, because the machine again, sorry. And so like that, the data pre-processing before the algorithms can learn, it's a very important aspect. And so we need to understand the data from a quality perspective, completeness perspective, accuracy, the relevance of each data attribute that we're doing, and on top of it, we need to prepare it. And the last one, or maybe another area where we also need to look at is, from time to time, the data, underlying data can change, right? The population may have increased, or maybe the data distribution may have changed, right? People would have aged. So there can be several other things like that where it is quite possible that data is changing. So we need to be able to bring in all these elements into the for the machine learning model to continuously learn from all
Excuse
of
me,
that.
sir.
Yes, yes. Is there a question? Yes, Mr. Siva Nagaraju.
Sir, you please unmute yourself and ask the questions.
Hello.
Sir, you are
Yes,
audible. Continue.
I can hear you. Yeah, please.
Last few minutes, I am unable to your screen sharing, sir.
Oh, is it? Let me.
No, sir. No, sir. It is visible to everyone.
It is?
Now,
Okay.
now it is visible, sir. Last few minutes, it unable to visible, ma'am.
Maybe it is your network problem, sir. From SAR's side, it is okay.
Okay, ma'am. Okay, okay, ma'am.
Okay, sir. Sir, you please continue, sir. Your side, from your side, it is okay.
Okay. Yeah. So I was talking about these four themes. That is, one is, the data has to be complete in all aspects, but at the same time, we don't want to unnecessarily feed the machine learning models with data that's unnecessary as well, right? So it is very, otherwise, the computational cost will increase, the amount of processing time will increase, and it may not even be necessary. And the machine learning model may also make irrelevant correlations with regards to what the underlying patterns are, especially. So you need to understand the that we have to provide our machine learning models with highly specific data, and source of data has to be validated, right? It is very important. Now,
Sir?
yeah.
Okay. Now it is audible, sir.
Now I'm out. Oh, okay.
Yes.
Yeah. Sorry.
Just for 1 second, sir.
1 second. Okay. No. So, for example, if I were to tell you that, look, I want to make a prediction on a financial model where I want to be able to predict what is going to be um, the bank statement, or sorry, what is going to be the amount that you will have on the 1st of next month, right? Would you be willing to share your financial statements for training the model? And would you trust somebody else with all of that data? We wouldn't, right? I mean, I don't want to share what my bank account balance is, or I'll figure, I mean, I'll be really worried if somebody asks for it and then say, oh, this is how I want to be able to pull that data, right? So there will be occasions like that where people would not want to share data which is in the real world. But then how will these machine learning models actually learn from that, right? That's where it is the synthetic data, or machine generated data will come in handy, right? That's most the topic.
Sir?
Yeah, it's created by
Sir, yeah.
some.
Okay, sir. No problem.
Oh my God, sorry. There's a lot of interruptions today, unfortunately, ma'am.
Okay,
There
sir.
are,
No problem.
yeah. Because there are a lot of personally identifiable information, quite highly private information that is there, right? So it is those kind of situations necessitate for us to create artificial data that is very, very close in terms of the real world data that we have. So even in my previous work where I'm in previous companies where I used to work in the organizations, we used to, even before the advent of AI, as pervasive as it is today, we used to actually
Sir,
functional testing or for some sort of performance engineering and all that. Yeah, I see there's a hand raised by Ms. Divya. Is there a question?
Divya ma'am.
I'm so sorry. That was a mistouch. Pardon me.
Okay, sure, no problem. Okay, yeah. So from time to time we need artificial data in order to, I mean, to be able to mimic the real world kind of characteristics, right? But now there can be different kinds of data. When we say data, data can be in any form or shape, right? There can be categorical data or numerical data or time series data or text data, right? Typically there are, as you see on the slide there, there can be structured data. Structured data means, you'll have it in tables. You say, okay, this is either a yes no kind of a thing, or you have, male female, those kinds of characters, or a table of red blue green yellow coloring or whatever it is. Yes, Mr. Ashok, there's a question. Mr. Ashok, you raised your hand. Is there a question there? Okay, let me continue. We can come back to that. Yeah. So there is tabular data that we can look at, and which is what most of the times we've accustomed to, right? We look at different kinds of data that we see, but more and more imagery and videos are also becoming are also necessary. Like I was talking about the multimodal world for LLMs and chatbots. Likewise, there is a lot of need for unstructured data too, and this is only going to increase, especially when we are talking about autonomous driving cars. We're talking about maybe traffic light sensing kind of use cases, or satellite imagery where we have to be able to predict weather patterns and things like that. You need a lot of images to be able to understand various kinds of real world use cases, right? So there can be either this tabular structured data with different kinds of different types of data requirements, or you need imagery and videos and all of that in order to feed your machine learning models, depending on what it is. But either way, there is a lot of that necessity today, primarily because the underlying data, the real world data, we can't use it from for various reasons. And things like GDPR, this is the European regulation for privacy. So it prevents a lot of the organizations and private personnel also from leveraging the real world data, right? Similarly, India is also trying to enact something. There is what I forget what exactly the name is, but there is data has to reside in India for all the organizations that for example, Twitter was asked to have servers in India for all the people who are actually logging in from India. The data has to reside here. So there are going to be different kinds of rules and different kinds of privacy laws that are being enacted. In California, there is something called a CCPA, California Consumer Protection Act, or Privacy Act, or something like that. So, so there will be different kinds of privacy laws that will prevent the misuse of data or use of data with consent. So you will see all these different kinds of things, right? So we have to be very careful as to what kind of data are we asking. But then how do we keep progressing on this, right? It is very difficult if we are not able to access real world data. How do we train our machine learning algorithms to be close enough to the real world to solve real world problems, right? That's going to be difficult. Sometimes getting real world data is also cumbersome. Cumbersome meaning it's highly effort and time consuming. If you have to, let's say, capture data for a particular use case for the very first time, you can't go door to door asking for all of that. Sometimes, our population surveys and all of that happen like that, right? But getting that real world data itself becomes very challenging, or it can be outdated very quickly. In fact, today I learned about, I was listening, like I was mentioning, right? I was listening to a podcast wherein they said Google has come up with um, a new feature or a new Gen AI based model, which is able to predict weather much more accurately than all the previous models in the past. Earlier, we were able to predict weather for up to 10 days. That's been the norm. If you look at your phones, or if you go to weather.com or some of the other places, they mostly predict with a high rate of accuracy for the next 10 days. But with this advancement from Google's Gencast or something like that, they are able to now take that forward to up to 15 days of prediction. Now, what does that do? I mean, it seems like just only 5 additional days of prediction, but that's a lot in terms of when we look at weather patterns, right? They're able to provide people with 2 weeks of notice whether there is a storm that's coming, whether there's some sort of a tornado that's going to hit them. So those advances in these kinds of real world problems are very, very important for people, but getting that kind of imagery and getting that kind of data, it becomes very difficult, very challenging, right? Now, in the corporate world, I can tell you my own challenge. We have delivery timelines. So which means a customer will come and sit on our head saying, I need this particular model to be up and running maybe by the end of next month. Now, if I have to test my model, my algorithm and deliver it for the customer, then I can't really wait. I don't have the time to wait for collecting or gathering real world data. I need to instruct my teams to say, look, guys, let's work with something that we can synthetically generate, and let's go ahead and do it, right? Sometimes it's having some synthetic data is better than not having any kind of real world data at all. We make certain assumptions, but then we call it out and we say, hey, here is how so that we are able to, overcome those delivery timeline challenges too, right? And sometimes it's hard to find real world data for all possible scenarios. I'll just ask you to think about this. In fact, I wanted to share that example of, do you think when ISRO or NASA are doing their calculations for sending a rocket into space, will they have all the possible permutations and combinations for real data to process? They won't, right? Because nobody has actually gone and done some kind of measurements. They probably will have 80-90% or maybe 70-80% of the data to look at, but then they will not have data for something which for a frontier which has never been even reached. Say up until the time that we're not gone to Mars, we didn't know what existed there, right? So how do you gather data, right? And some of this Mars rover and all of that, they were actually sent, or they were built to be able to gather data so that they could calculate and validate their assumptions and things like that, right? So sometimes we will not have real world data. We can only make certain assumptions and work through that. So in all those kinds of cases, synthetic data is becoming it's the way to go, right? Because it allows for rapid data generation, which is tailored for a very highly specific need, be it in academia, be it in the corporate world, in the industry, wherever it is, right? Now, I would also talk to you about, this is the advantages of the synthetic data. It's highly cost effective because, you have a lot more control on what kind of algorithms do you want to use, what kind of coding you want to do, how deep or how many records you want to have. So it's a lot more easier to work with the synthetic data, right? We don't violate any kind of data privacy or security concerns, right? And some of these tools, when we work with to generate the synthetic data, scalability becomes, we are able to overcome scalability issues. So let's say I want to be able to generate 10,000 records for my machine learning model. I can do that. I may be able to use the synthetic data generation to be able to even create 1 million records and feed it, right? I can control the diversity of data, right? I can look at any kind of distribution. I can add weightages to each of the categories that I want to say. Same in the simplest one, like example that I was giving is, I want a male and female ratio of, let's say, 40 and 60%. That adds up to 100%, right? And I want to create 10,000 records of male and female synthetic data. Then I can generate it with roughly about, that ratio of 40 and 60%. But now if I add more variables to that whole combination, saying, within the male population, I would like to have, within that 40% of male population, I would like to have a data distribution of 10% of infants, 10% of kids who are up to the age of 10, 10% of the age people who are in 0 to 20, something like that, 10 to 20 or whatever it is, like that. I can provide different distributions there. Now, even in the female, this thing, when I say I can add variables, then that becomes it. Then I can add another layer of it, which is I can say those who have graduated with in commerce, those who have graduated in engineering, whatever it, right? So you get the drift that we can add additional variables to make it as complex as we need, or as real, as close to all the assumptions that we are making, so that diversity of data can be achieved with synthetic data in a much more rapid way than actually what we can do with real world data, right? So there are, for those reasons, it gives us a very good starting point, right? Now, yeah, you may ask, or you may be thinking that, okay, we got it, right? It doesn't really mimic the real world scenario. But what if, because I'm creating this data, right? I'm creating this data with certain assumptions. What if there is bias, right? Yeah, there can be bias. I'm not saying that there won't be bias, but yes, the machine learning will not be 100% accurate. But that is where it is important for us to understand the process of repetitive or iterative ways of keeping that synthetic data updated in a continuous manner, right? If we don't do that, we probably will achieve maybe an accuracy of 50% in the first iteration, because there is bias, there is some other issues or whatever it is. We may only achieve an accuracy of 50%. But as we are able to understand and look at what that accuracy numbers are, get some real world feedback, and improve our machine learning model, it'll, over a period of time, that accuracy will slowly start improving. And as we gain some additional feedback points, then we would be able to improve the quality of our synthetic data also. That's also a very, very important aspect, right? Now, I want to, because I was talking about synthetic data and data scarcity and privacy, I want to share one example, recent example that happened. This is from the official websites of the United States government, the Federal Trade Commission, right? And their job is to protect America's consumers. There used to be a company called Xmode, and now they're rebranding as Outlogic. But what they were doing was they were collecting data of different people from the geolocation data, and they were selling it to other third parties. Now, what they did not disclose was that they were collecting this geolocation data without consent of the users. And that's not ethical at all, right? So we have to be very careful today in a day and era where there are so many different ways in which data is being collected, right? In fact, it should not come as a surprise to all of you that when you speak to somebody, your friend, your family members, saying, hey, I'd like to buy that leather wallet or that leather bag, right? And then you go open a Facebook or an Instagram or something, you'll start seeing ads about leather wallets or leather bags. It has happened with me, right? I'm pretty sure it must have happened with a lot of you also. Maybe we do not think so much sometimes, or we do not pay too much attention. But if you look closely towards your settings, the privacy settings, and what kind of data is being collected underneath the hood for every single app on the mobile or on your devices, you will realize that there is a lot of different kinds of data that's being collected, right? Is it ethical? Is it agreed upon? Is it with consent or without consent? We don't know, right? But you all as students, as PhD or researchers, as faculty, when you are trying to gain, or collect data for different kinds of experiments and all of it, please make sure you become very sensitive about how you are collecting, what kind of data you are collecting, right? Because otherwise there are chances that it could either be called as plagiarism. Somebody else has used it, you have been used it, or it could also, sorry, not plagiarism. It could also be, it could violate some copyright content or whatever it is, or it could be very sensitive data and so on and so forth. So there is a lot of worry around data and the data being used. Okay, so there is always going to be this conundrum or this problem that on the one hand, our models are becoming more and more complex, our models are becoming more and more bigger, the large language models and the neural network models, all of that are so big, which means in order for training them, you need data, but you also have this problem as to how do I get that data to train this, right? So therefore, it's always going to be that tug of war, or that push and pull between these two things. So please be very, very sensitive about that, right? And even in our models that at Oracle within the marketing group, when we build out some of these machine learning models, we have used our own internal proprietary tools to be able to generate synthetic data, right? In order to feed into these machine learning models, and only when maybe some customer or some of our customers are consenting to let us use their data for improving or enhancing the data science models, only then we use their data to train it. If not, we are not allowed to touch even a small part of the data. And every single time we also release a model or maybe make an external announcement, we also have to make sure that we mention that no data is being used in order to train the model directly when we collect or when we store the data. So you will look at these kinds of different aspects when you are talking about synthetic data for any of the machine learning models. And so for these reasons, the generation and the use of synthetic data becomes even more necessary, right? So that's very, very critical. Now, moving on, there are several techniques that we use for that. There are statistical methods, very simple ones, where you probably write a VB script or something. You can probably generate data within an Excel spreadsheet, and maybe you get distribution of data from the real world. Maybe you don't get the actual data, but you probably understand what is that distribution. How do you get that distribution? You probably will look up, there are ways in which we can search for, hey, what is the population distribution? There will be some publicly available data sets, right? You would understand the the distributions of the data from these data sets, and then you can apply the same kind of that distribution, or use that same kind of distribution weightage in your synthetic data generation tools as well, right? Like I gave that example of, I want to have I want to generate 10,000 records of a population size for behavioral data, 10,000 records of male and female, where the male population percentage is 40. I want 60% of female population percentage in the distribution. It will generate it. And the more complex you want to make it, you can always do that, right? That is one. The second type is the machine learning approaches, where you can have rule-based data generation, and you can specify these rules as simple and as complex depending on what kind of outcomes you want. And this is where most of a lot of the data generation actually happens in the rule-based space, right? Because companies and organizations understand that there are certain logic with which the business logic is being written. So you would be able to identify certain rules, and based on those rules, the variables and the weightage that you provide, you would be able to write the code which will say that, hey, this is the rule that I want to be fulfilled, right? Sometimes there are already pre-existing data sets that are available on the web that you can use for training models, for generating new data also. So you can take these data sets as your seed data set and train your models for generating new set of data. And again, there is machine learning based generation for generation of data for training some other model as well, right? So we are playing around somewhere in this particular area as of today within our teams, but there could be other uses too. We have not explored yet the generative models, but this is something on our radar too, where we have it on our one of our product roadmap too, to be able to generate data sets, with the help of the generative models. But given that we are still building out features, we have not explored that whole area. But conceptually, we are debating internally within our teams as to how the generative adversarial networks, the GANs, actually work. What they are able to do is that you'll have it's almost like a, a how do I say in the layman terms, like a debate. You'll have a discriminator and a generator, right? So the generator will actually generate that generate data, or it will generate content, and the discriminator will try to prove that it's not useful, right? So there will be two opposite sides, and so one will try to outweigh the other, therefore bringing up the quality of the the overall content of the data that's being generated. And at the same time, that your model is getting better and better, right? So there are generative adversarial networks, or GANs, which will be able to produce that data by constantly debating amongst within the network itself. And then there are variational autoencoders. We have not explored this particular piece yet, but there are also variational autoencoders that will allow you to generate the models, right? So these are things, and I'll provide some citations for that. What these all the models will do is they will allow you to either train the model, right? Which means you can use this data set in order to directly train your ML models. That's number one. Or you can augment the data. Say, for example, if you are I have, let's say, maybe 10 attributes which are available, but I'm not finding certain two other attributes that are required, or two other features which are required for my machine learning model. Then you can use it for augmenting the data, right? You can add that and either reduce bias, number one, or the missing data set that is there, you can probably augment that. Let's say your model is also not being able to converge, then you're able to generate this data, augment it in order to help the model learn, right? In the one of the earlier slides, I showed you that you keep this this one, right? If this is the original data, if we understand the distribution, synthetic data can pretty much mimic the original structure. It won't be exact like to like, but it will still retain the original structure, right? It may not be the same. So you can do a whole host of these kinds of experiments with the synthetic data generation, right? And then what can you do with the application of this synthetic data, right? And you can apply it for different industries, right? For example, I was telling you, medical records are highly private. You can't access that, right? But I need the data in order for me to train the model for maybe, let's say, some drug research, or some sort of a health research. Then such synthetic data, which probably is trained on all the synthetic data, so that is generated from previous or some similar kind of records, that can be done, right? Sometimes the data is provided by masking as well, right? By various groups. So we can look at that as well to say, okay, with this masked data, or stripped out data, how do I generate synthetic data, right? So that is one application within the healthcare sector. Similarly, for computer vision, right? How many times have you also looked at, hey, tell me that you are not a robot. You're not a robot, right? So a lot of times we get these kinds of questions where there are images which have traffic lights, or images we have to identify which are the images where there are bicycles in it. And behind that, you need somebody has to understand that, right? But how are you generating those images? You need those kinds of things to be able to understand, right? So all of that, for these kinds of research, you need, for computer vision or for vision-based large language models and all of that, you need imagery as well, to be able to apply across industries. Same thing applies, like I was talking about autonomous driving cars too. You need that, right? So there are several applications there. Now, what kind of problem that you're trying to solve will help define what type of data that you are really wanting to generate. And that is going to be very, very important. In fact, I was reading an article where they said that by end of 2024 or by end of 2025, almost 60% of the data that will be used for training machine learning models will be via synthetic data only, right? Which means that this is increasing every single day. The amount of people who are generating synthetic data is increasing rapidly, very, very rapidly. Even we face a challenge. We don't get customer consent to use, like I was mentioning, right? We don't get that customer consent to train the machine learning models with real world data. So we all have to look at, I have this business problem, and therefore I want to apply that for either healthcare or for retail or for it is automotive or energy sector or utility sector or whatever it is, and then be able to generate that, right? Okay. Now I'll also talk about quickly, this, where is that? Two things. Okay. Now, what will be the considerations that you will have, right? I mean, so far we talked about generating the data, but I think I did mention at one point in time that the data that you are going to create, the model that you are going to use it for training, it will only be as good as the data that you train it on, right? What do I mean by that? That let's say if you generated very simple kind of data, your machine learning model is also going to be as simple as the data that you train it on. If it doesn't closely mimic the real world scenario with all the complexities or with all the different kinds of data distribution, with all the kinds of the structure that you really require within that, then your model will not do well. Okay. And so therefore it becomes, because it's one of the foundation for training the models, right? And second is that if there are going to be a lot of challenges also, right? It's not easy. When I say we have to do it, it doesn't mean that you will be able to get the same kind of data distribution every single time. Yeah, there will be chances that because of the complexities, and we don't understand every single assumption or every single complexity in the real world as well, we may not be able to exactly mimic that kind of a structure, right? So these will continue to become challenges, and every single day we stumble upon a different kind of a challenge when it comes to synthetic data. It is not nearly as accurate as what the real world problem will tell you, right? That's one. But remember the fact that even in real world, who is dictating that data distribution, right? We don't know. That data distribution may be changing every single minute, every single day, right? So as long as we are able to get close enough, then I think that's good for us to at least have a great starting point to start training the machine learning models on, right? And over a period of time, it will improve. This is the place where I generally and please pardon me, I come from an engineering background, and plus because I worked in the industry with a lot of timeline and delivery timeline considerations and all of that. I look at I encounter people who are put on a research hat, right? So for us, because we have a timeline limitation, we have to deliver within that timeline. But I've seen some of my the research team members, they would work as if hey, there is plenty of time and the research has to be ideal enough, right? So now that's why I said, depending on where or what kind of hat you are wearing, right? Your business problem or the problem that you are trying to solve, if it requires an ideal solution, then you may want to have the data quality really, really good for you to be able to get to the actual outcomes of the model. But if your focus is more around the timeline, or maybe get something out there which is important to at least run, and I know that I can iterate and probably get to a better outcome, then even a 50-60% accuracy of the model will also do good, right? So whenever you are approaching a problem, look at what are the outcomes that make for it to be successful, right? That the successful outcomes, what are the successful outcomes? Is it really good quality of the machine learning model that you are looking for? Or do you have a timeline within which you need to work and finish this, wrap it up? So let that drive the type of effort you put in, the type of complexity you actually do it with the synthetic data. That's very important, right? And this is always going. Sorry, was there a question? No, okay. Yeah, so this is always going to be sorry, I lost my train of thought. Saying, so this is, so we need to always think of the bigger picture, right? So generating synthetic data is one thing, but what is it that you are generating it for, and how good a quality of that data are two different things. Right? So look at the kind of issues and then you do that, right? Now, if that is done, then let's talk about the, um, the the popular data sets that are available. And for some of you who have already played around with it, it may not be very new, but let's look at some of these data sets. Now, there are some machine learning data set resources which are already publicly available. So we tap into some of these data sets as a starting point for our own use as well. But if beyond this, also we look at, like I said, we look at a combination of either a public data set that's available. Sometimes it's also possible that you may have these on GitHub or some other repository where these data sets are being made available. Or we also look at then using this as a seed and then create our own data internally for machine learning. Okay, and then in a minute I'll share a few of the resources where there are different kinds of resources. The links for some of these data sets as well, and we'll look at a couple of these sites. Then Google's dataset search, that allows us to do that. Microsoft publishes a research open data set. Amazon also provides for a lot of these data sets that are available. Similarly, UCI and data.gov from US, there are some government data sets which are available for everybody to look at. Okay. Now, I don't know what kind of topics that you are working on. And if there are certain specific topics that you're working on, then we can probably either I can give you maybe additional resources or maybe put you in touch with people who may be able to guide you better. But like I mentioned, right, I mean, before you jump into saying how do I create a synthetic data, try to understand what kind of problem that you want to be able to solve. Then comes the what kind of outcomes you want to be able to arrive at, right? And there are all these different kinds of just like the Gen AI advances that we talked about, there are going to be a lot of different tools which are emerging. And in fact, one of the areas of research can also be creating Gen AI based data generation tools, because there are a few of them. Mostly .ai is there. Then there is another tool set which is I forget what the name is. There are 2 or 3 other tools which have come up, but it is an interesting area where we can pretty much with the help of generative AI also leverage or create synthetic data, right? Now quickly let me go to a couple of sites. I will share that also. Bear with me a minute, please. Meanwhile, are you all following me, or are there any questions that you have to ask?
Good evening, sir. Hello, am I audible, sir?
Yes, Miss Anita, yeah, please.
Sir, Kaggle data is also standard data. If we create this synthetic data, it is similar like a Kaggle data.
Sorry, what is that?
Kaggle data is a standard data set. The Kaggle have some standard data sets, right? And if we create the same data set for synthetic data set, it is similar one or different one?
I didn't quite catch your question, ma'am. I'm sorry.
Kaggle data set
Yeah.
used for machine learning purpose. If we use same Kaggle data set to generate a synthetic data set, we get similar result or something different result.
When you say, I mean, that may be a very, I understand what you're saying, ma'am. But see, the answer is not straightforward to that. The reason I say that is that when you talk about Kaggle data or what, underlying, there are two, three things. One is, what are the outcomes that you're looking at, right? Are you looking at what kind of complexity you want to build out? What algorithm are you using in order to generate that data? It may be different, okay? And some of it would also depend on, are you using some sort of randomizer behind that to generate that data? It would change, okay? You can't guarantee the same exact kind of data to come through with, especially when you're looking at two different models and all of that. That's not guaranteed. What you can do is, to a fair degree of confidence, you can mention that given if you are giving the same kind of data distribution and categorization, then you would get similar kind of data, but not exactly the same.
Okay, sir. Thank you.
Yeah. Okay, 1 second. Let me. There's.
Hello, sir.
Yeah.
I have small doubts regarding generation of synthetic data.
Mm-hmm.
So you are saying for synthetic data generation is only for machine learning models, or is it suitable for deep learning models? Because when we are using synthetic data generation, in the sense, I have faced one problem regarding data imbalance issue. So there we are generating synthetic data. So as the data set size increases, so machine learning models won't work properly. So it will go for deep learning models. So there I have faced this class imbalance issue, especially in the data set concept. But you are
Okay.
mentioning only machine learning models for synthetic data generation.
So when you say deep learning models, and what kind of, how did you generate the synthetic data?
So using generative adversarial networks, GANs.
Okay, and you had you said class imbalance. Then when you say class imbalance,
It's a class imbalance.
okay. And in order to sorry, so when you say class, you had class imbalance. What happened there with your machine, the learning of
Yeah.
the deep learning models?
Yeah. Most of the machine learning models can able to get good accuracy because of less data. So as the data set size increases, so at a certain point of time we are facing this class imbalance issue. So there the majority or minority samples not at all balanced. So because of high imbalance issue. So at that context, we came to know generation of synthetic data. So previously we are working with like undersampling, oversampling to manage the class imbalance issue. So now it will comes to a deep learning part because of data set size increases. Machine learning models won't support, even though we are generating synthetic data using existing data level methods. Hello. Hello.
Sir,
Hello,
your
sir.
mic is mute.
Sorry, yeah, mic is muted. I know. Sorry. No, so I will, what I will do, I mean, we did not encounter that, Mr. Suresh, but what I will do is I will put you in touch with one of our team members so that, we are able to talk more about that, because that for deep learning models, personally, I have not encountered that. Okay. It's something which we have not seen that. The oversampling, undersampling, yes, we've seen that. But this, I have not personally witnessed it. So maybe I'll try to understand a little more from you. Maybe we have already seen some of it, which I've not been made aware of, but I'll surely get back to you on that one.
Yeah. Okay, sir. Thank you.
Yeah. And Dr. Kalavati, I'll sync up with you separate.
Okay, sir.
Sir, one more. Hello, sir.
Yeah, yes, please.
Yeah, I previously worked on the data set called UNSW 18 CSCS data set, like related to network intrusion detection system. So for classifying various attacks. So I consider only for a particular day in a particular session, in the morning session only. So because of huge volumes of data regarding these two data sets, so there I plan to generate synthetic data. So that's why I'm suggesting machine learning models not at all fit for generation of synthetic data. So that's why that at the time I go for the GN models and LSTM, long short-term memory model. So
Yeah.
that's why I thought that.
No, what you're saying, it is right. But like I said, it's I don't know the magnitude of data that you're trying to look for, or what kind of data distribution you're looking for, right? So it may, I'll have to probably, that's why I said, maybe we can take it separately. I want to understand that as to what kind of issues that you are facing. It may require a little more deep dive than this. And also I'd like to bring in, like I said, one of my colleagues into that conversation separately, and maybe we can help solve that, Mr. Suresh.
Yeah, no issue at all, sir. Because a lot of the papers I have referred when I'm doing my research. So most of the machine learning models can able to give 98% of accuracy. Even I used deep learning models. So because of this class imbalance issue or generation of synthetic data, so I am not at all able to get at least 85% of accuracy.
Okay.
That is the difference I have seen at that point of time. So 2 years back.
Okay. No, fair enough. No, like I said, see, I bring more of a see the I've personally not encountered that issue because we are not actively working on some of these deep learning models, to be honest. So I may not be aware of that entire issue, what you're talking about, Mr. Suresh. But that's why I said, I'll probably have somebody who's probably seen that. I'll inquire around and probably help you out in solving that problem. That's one. And we sometimes put on a very siloed practitioner hat to solve a very specific problem within our purview. So sometimes that also doesn't allow us to work on these kinds of problems. So I'll be glad to assist you if in finding out the solution for that.
Sir, do you have identified any tools that will automatically generate synthetic data which is similar to our real data set?
We built out some, so that's why I said, we built out our own internal tools.
Because of instead of identifying the each and every record, instead of identifying number of features that are available in given set, reducing the number of features in the given set, so that whether those features are relevant to related data set or not. That analysis we are doing normally. So instead of doing this kind of analysis, because of generative AI and large language models, is there any tools that automatically generate synthetic data which is similar to what are the records or what are the attributes that are available in the original data set? It may be collected from either UCI repository or Kaggle data set or any other data sets.
There are. So in fact, some of the data sets that we're building out, some of the data sets that we are building out, we build out our internal tools accordingly, right? That's why I said they are proprietary and I can't share them on a large forum like that. And that's why I was showing more about the open source data sets that are available, more from a broader perspective that addresses for a lot of the people. But I can't show you the exact tool, but I can get you to talk to one of the guys who has actually built out that tool within our team. We can talk more and probably provide you with the idea of how to go about that.
Okay, sir. No issue. Thank you, sir.
Okay. Yeah. Because I mean, like I said, what we do is we build out our own proprietary tools that I can't share openly in a public forum for us because of various reasons, right? And therefore, so we can only talk more from a directional perspective, saying, hey, what kind of tools can be built out? So I'll probably also check internally as to what is the viability for us to talk about the tools that we have built out. If we do get clearance, then we can probably share that with you and then show how to tackle that problem.
Yeah, definitely, sir. Thank you.
Okay. Yeah, I mean, see, we also like I said, we also stumble upon some of these kinds of issues from time to time. We don't have answers to every single one of them from all the data, but yes, I mean, those become challenges for us also to look at.